Thank you. All right, so the plan with this talk is to really start from the very beginning. We're going to talk about Sparklyr. Just to give you an overview for the ones that are here, Sparklyr is a new interface to interoperate with Spark using R. So I'm just curious, before we start, if you could raise your hand, how many of you have actually worked with R in any way? Doesn't matter. OK, that's mostly all of you, which is great. And how many of you have worked with Sparklyr or have heard about it? That's maybe a third or a half, which is great, because my plan is to start from the very beginning. So if you haven't heard about even R, this talk should get you up and running. And if you are familiar with Sparklyr, that's great, and it'll give you the updates. If you've never heard about Sparklyr, we'll also go from the very beginning, and you'll have an update exactly what it is and what's the purpose and what's its future. We have the talk scheduled in 2 slots. It's up to you. I mean, the plan is to basically stop after the first 30 minutes, just take a break, and then just continue. The talk is split in 2, mostly starting from the beginning, what is exactly Sparklyr, getting you all the way to what has been done and what has changed in Sparklyr in the last 6 months. And then we're going to deep dive a little bit more into the architecture and some of the most advanced, common and both also advanced use cases. And with that, I thought it was really important to start from the very beginning. There's this common knowledge that says that in order to really understand something, you want to ask yourself 5 times why. And I'm going to start from the very beginning of why Sparklyr. And that question basically brings us back to what is S. I'm also curious, how many of you have heard about S as a programming language? Right, that's fewer than the people that have heard about R. But basically, our precursor, it's the S programming language. It was a language designed for statistical computing. And I feel like if you can understand this slide, you're probably set off for the rest of the talk, because it makes a lot of sense, kind of like what we have here. And the creator of S was John Chambers. And he created S as a programming language when he was at Bell Labs. And this is the first slide that he ever sketched when he was proposing the creation of S as a programming language. And quoting him here from one of his previous talks, he mentioned that back then on Bell Labs, it was a place where computing was done by calling Fortran subroutines. So this was already a while ago, but what is interesting from this slide is that the main problem that S was trying to solve is to give users a better user interface while dealing with these complex systems written in Fortran. So what he has here in his diagram is basically he's representing the Fortran code base as ABC. It's just a black box from his point of view. And he's creating a wrapper around it, which was the intention of the S programming language. And basically, the idea is that it was going to help people be more productive while doing data science without having to necessarily go deep down into the specifics of how the system was implemented in Fortran. That's the general overview. And obviously, like any programming language, there's trade-offs, right? And even back then, this was the comment that, quoting John Chambers, Bell Labs management mentioned. It says, well, S is great, but serious data analysis will always be done in Fortran. And to this date, there's this trade-off is still true, right? Like if you look at R as a programming language, and you need to do some GPU optimization, or you need to do some very low performance, high performance, low architecture programming, you probably don't want to choose R as your main programming language. You want to choose it when you're creating interfaces to make data scientists more effective, and you want to increase productivity. And to me, this is interesting because basically these are not new news. It's something that it was there from the very beginning. So what exactly is R? Well, first of all, R is very close to what S was. In Wikipedia, you can find the definition as basically built on top of S with enhanced lexical scoping. But there's something a little bit more intrinsic going on the difference between R and S. You can see R as a modern version of S. And to me, the big secret behind R, it basically has to do with the community behind it. The package manager in the R community is called CRAN. It's the equivalent of NPM or for Node.js or pip install for Python, etc. So it's just a package manager. But what it makes it really different is that there's a big community of data scientists. And the type of packages that you would see there are more closely related with data science and modeling, and less so related with software engineering. And from 2014, this community has been growing consistently. This is a tweet from a data scientist, Matt Dancho, and he created, just for fun, a model forecasting the growth trend over CRAN packages. There's about 10,000 packages today, and they're heavily focused on the data scientists, and mostly following the same roots of creating a programming language for statisticians that has grown to be also adopted by data scientists. And talking more about the specifics of R as a programming language, there's a couple principles that, again, I borrowed from John Chambers from one of his Use R talks. And there's 3 principles. The first principle, it says that everything that exists is an object. That probably sounds familiar from other programming languages. Same for the second one. If you think about functional programming languages, everything that happens is a function. So those are pretty 2 common characteristics that you can find in other languages. But the third principle is a bit more particular to R. And that one says that R is built on interfaces to many R and non-R algorithms. A lot of the languages that we see today when we create a new language, or when people create a new language, those languages also tend to re-implement the main core routines and the main algorithms on that particular language. And in a sense, R, being an interface language that attempts to increase productivity on the data science community, it's more open to also including things that are not even written necessarily in R. All right, so going back to the talk, I think you have a very good foundation to understand the packages around R and the R community and R as a programming language. How does an interface to Spark would look like in R? We can obviously apply these principles, ease of use, being able to interoperate with multiple languages. And what I have here is basically what Sparklyr is. All this is code that it's compilable and that we can try out. But just to walk over this in order, in R, you also want to include import a library in the same way that you would do on Python or on Scala. Here, what we do, we say library Sparklyr, and that's basically importing the library. That's pretty standard from any programming language. But the first interesting concept, we have a function called Spark install. And what it does is what you would actually expect it to do. It basically installs Apache Spark. Now, that's pretty straightforward in some ways. You can go to the website, download it, unpack it, unpack it on the right directory, change permissions if needed. In Windows, it's a little bit trickier, but it basically works in the same way that you would expect any other function to work. And what it does is basically installs Apache Spark, which for someone that is getting started in Apache Spark, it might be one of the easiest ways of getting this installed, especially on Windows. So in this case, what we're getting is a message that Spark 1.6.2 is already installed, which it is already on my machine. But back to this concept of ease of use, to us while designing Sparklyr, was really important to give data scientists the tools to be very productive from the very start. The next concept is also what you would expect from any interface interoperating with Apache Spark, and it's basically connecting. So in this case, we're connecting in local mode, but you could also connect in yarn client. In yarn client mode if you had a cluster, or you could go, for instance, directly to one of the cloud providers like Databricks, IBM, Azure, EC2, etc. So in this case, we connect to master, and it's basically a one-line call. If you wanted to connect based on version, you can also pass those parameters, and it basically gets you connected. So once you're connected, it's usually the case that the first thing that you want to do is you want to analyze some data. In the R community, we have multiple packages that allow you to analyze data. One of the most used packages is called dplyr. And dplyr is it's a grammar for data manipulation. So think about it as using SQL-like operations, but in a more concise and more structured approach. What we're doing here is, first of all, same thing. We're importing a library, and then we're copying data. In this case, the data set that we're copying is called empty cars. It's a very small data set, but we can take a look at it, and it basically tracks few specifications of different vehicles, and you can see things like cylinders, the weight of each car, and the miles per gallon. So this is very simple analysis. You can do more complicated stuff that we'll get to, but just as an overview, this gives you a good start on how to do data analysis on R. There's obviously the case where especially data scientists are more interested on building models apart from analyzing data. And one of the key design principles that we followed is we wanted to make sure that modeling is as easy as data analysis. So in this case, for instance, what we can do is we can run a linear regression over the same data set. So suppose that we wanted to know if miles per gallon are somehow correlated with the weight of the vehicle and like the horsepower or some other feature. So really the only thing that we need to do is we need to call a function called MLlinear regression that is going to run this particular model. And it makes sense to mention that even though we're getting all the results directly back into R, if we were to look at the Spark UI, like all of this it's running basically on Spark. And to the R user, and talking about, again, of seeing R as a user, as a language interface to something, in this case being Spark, it's natural for data scientists to work against Spark without necessarily knowing all the details in their day-to-day. So yeah, you can see here that linear regression is being executed. And there's a good amount of users that they're already familiar with SQL, and they're interested in using SQL to the full extent of it. For that, there's a library called dpi, and again, you can make use of these with Sparklyr. It can be as simple as just selecting the number, like all the records, and you can browse through them from RStudio. You can do more interesting things, and again, as long as you are familiar with SQL, you would get what you would expect, right? So what happens once you outgrow Sparklyr? And that's one question that it's always gonna come, and it's always gonna happen, because as you're building an interface, and especially over a thriving community like the Spark community, where there's always something new, how do you deal with new functionality that is not already provided by Sparklyr? And the answer here is by using extensions. And there's two ways of doing extensions or extending Sparklyr. One is to call Scala code directly from Sparklyr. And the way you do that is with an invoke function. In this case, what we're doing is we're retrieving the Spark context, which you're probably familiar with. And then we're calling, we're getting the version attribute out of it. So since we installed version 1.6.2, that's what we're getting from the running Spark instance. And there's yet one other way of extending Sparklyr, which is by using Scala code. And again, back to this concept of looking at R as an interface language, if there's nothing wrong with extending its functionality in the native language from where the interface was, from where the system was created. And in this case, it's Scala. So Sparklyr provides functionality to integrate Scala code directly into your package, that then you can call this function compile package jars. And that's basically going to give you a jar that gets deployed when you connect to Spark. And so it's really, it's it's really unbound in the sense that as long as you're willing to write Scala code and make the life of your data scientist easier, you can always still write your code on Scala and grab it over our interface and make it available to those R users. So this pretty much covers like a high-level overview of what Sparklyr is, from installation, connection, doing analysis modeling, and extending it. We'll definitely talk in more detail about each of them, but definitely for those of you that haven't heard about anything or haven't heard about Sparklyr, this is like a good primer of what can you do with it. Catching up with what has happened in the last 6 months, I'm just going to walk you through what features have been developed and what things have changed. So this project started on April 2016, so that was last year. We announced it on UseR, same year, and we released it to CRAN, which is our main distribution center for any R package on September. The package got certified with Cloudera on October, and some other RStudio products as well got certified as part of this effort. And the features that we basically covered on this previous slide were all features from the 04 release. And so basically from day one, we wanted to have a framework that would provide all batteries included, kind of type approach that would get data scientists up and running in R. January this year, we released another major version, definitely less features than the original release. We've also been patching it as needed, especially to cover functionality with partners and external packages. So for instance, one of the updates that we had to do was when dplyr got upgraded from version .5 to .6, we integrated that functionality back into Sparklyr. And same for Databricks. Databricks already announced that they're supporting Sparklyr on their Databricks cloud offering. And for that, we backported a fix to make this available on their platform. We also added support for Livy. Livy is a REST interface into Apache Spark, which I'm sure some of you might already be familiar with. The great thing about Livy is that you don't need to be co-located with the cluster when you're doing analysis over Spark. So you can have a web interface with authentication and be working from your desktop against the cluster without having to be physically or virtually connected to the cluster. So we added support for that on Sparklyr 05. And there's always improvements that we do across the board. Some are smaller, some were bigger, but those were a bit more incremental than the main features. For the current release, and again, perhaps something that I haven't mentioned that I should have mentioned is that Sparklyr is Apache 2 licensed, and it's fully open sourced. You can find it on GitHub under RStudio Sparklyr. So it's really no secret what we're developing this version. So that's the landing page for this Sparklyr package. If you want a little bit more documentation, you can go to spark.rstudio.com. And that's a bit more focused to the end user, but definitely it's a good resource. But my point here is that there's really no secret on what we're doing for the next version, but it's good to recap. One of the biggest features that is currently missing for Sparklyr, or at least that was missing on 05, is the ability to execute arbitrary code. And by arbitrary code, I mean arbitrary R code. And that's one of the features that we're working on for the current release, which is in development. And there's a bunch of additional improvements, integration with other packages like Broom, which helps you clean up your models once you have the results produced by MLlib, in this case, being the one provided by the Spark community. Yep. So this covers pretty much what the roadmap that we had since launch all the way to, literally today with the development version. One more interesting piece of information that I wanted to share today, it's the creation of a new project and initiative. This project is called Spark Install, and we covered already what Spark Install does within Sparklyr. However, as we all know, the Apache Spark community is it's a cross-language cross-language. It's a cross-language effort that supports Python, supports Scala, supports Java. I've seen some implementations with Eclair.js of even JavaScript. And we got approached by Microsoft, by their machine learning, the Azure machine learning team, to work together and make these a project also available to the Spark community. So today we're launching this initiative. It's basically a joint effort to make the libraries from that helps us install Apache Spark from Sparklyr widely available to the community. So there's an R version which we're planning to integrate back into Sparklyr, and there's also a Python version. Both are currently in very early stages. Even though the code base is already functional, we're planning to do the work on publishing it to CRAN and also publishing it to the Python package manager. And shouldn't be far away from today, but basically this is also a shout out for the rest of the Spark community. If someone feels passionate to help and make the Apache Spark install better, there's definitely, I think, room to grow with other programming languages. So far, we have Python and R. All right, so I'm going to get started with the architecture and to leave some room for questions. Let's see where if I find my presentation. Did I close this? Anyway, let me just. So switching gears again back to our presentation, I'm going to cover now in more detail what we came to talk about today, which is a deeper dive into what Sparklyr is, how it was built, and especially for those of you that are more technical and are already working on extending Spark in more advanced ways. Even though this talk is about R specifically and Sparklyr, a lot of the patterns that I followed are patterns that you can apply for other even programming languages or for other components. Definitely, Sparklyr was heavily inspired on the work that was already done by by extensions like the Python extension on Spark and Spark R as well. So the general overview on how Sparklyr looks like and how it was initially built looks like this. As you have probably already figured out, there's a client component to it and a backend. The client is basically all the functionality that lives on Sparklyr itself. It's the functionality that allows us to connect, to install, to run a machine learning model, etc. However, what happens behind the covers is a little bit more interesting. We know that in the Spark world, a lot of the processes get started with Spark Submit. And it's probably still the primary interface to get things initialized in Apache Spark. And the Sparklyr client does exactly that, what you would expect. It basically calls Spark Submit and runs an Apache Spark application on the background. What gets deployed when you run Spark Submit is what we call the Sparklyr backend. And this is basically a set of Scala files that allow the Sparklyr client to interoperate with the Apache Spark backend. The way it works and this architecture is heavily inspired by the original work on Spark R from Shivaram, and it probably matches almost one-to-one, at least on the Sparklyr 04 release. The way that both work is that they both start initialization through Spark Submit, and once the backend initializes, there needs to be something that tells the Sparklyr client how to connect to the running application. The way that it was done on Spark R and also on Sparklyr 04 was using a ports file, and this is basically a file that sits on disk. And this basically means that it was pre-assumed that Sparklyr would be running on the driver node on the same node where it was getting initialized. So the next step would be for Sparklyr to basically read that file, it can figure out where the file specifies which are the ports in which the backend is running, and then it opens a socket and connects to the backend. All the communication is done in a binary format, and this was mostly done for performance reasons. So yeah, so I think this covers the big topics. Spark Submit saves a file that Sparklyr reads and then communicates back using sockets. While this model worked well for a while, one of the most challenging pieces, I think, of troubleshooting time that I spent was while dealing with Windows on Windows platforms, both from Spark install and from the connectivity point of view. And I think that the two big differences between Unix platforms and Windows platforms was mostly that, well, first of all, when we're installing Apache Spark on Windows, there's a set of libraries that need to be installed called WinUtils, for those of you that are familiar with. Those are not currently, to my knowledge, unless I missed something on this conference, are not distributed by Apache, by the Apache Spark project. So that's something that we had to consider. And on top of that, when we're doing the connection, you could expect that reading a file, especially when you're trying to deal with multiple platforms, you end up having to special case things like really long paths where the system doesn't support long paths, and then you end up having errors or specific systems where, say, the permissions are not right, et cetera, right? Or Apache Spark is mounted on a very specific directory or way. So in order to simplify this, and let me see if we still have a little bit of time before the break. In order to simplify this, our first approach on a Sparklyr 05 was to get rid of that ports file. So rather than having the backend write a file that we then have to read, we moved into a proxy, or what we call a gateway mode, in which once Spark submits and starts the backend, we basically, the backend is already running on a well-known port. We chose port 8880, but this is configurable, obviously. And once we know this port, basically, all communication is done through this port, through port 8880. If we need an additional port, we can query the backend to get a new socket with a different port number that we can use to connect to this particular backend. So one interesting question here is, well, what happens if I want to have multiple instances, or what happens if there's already multiple instances running? So what happens in that case is we added functionality on Sparklyr to be able to proxy particular connections to the right backend. So this same socket connection on port 8880 has the ability to redirect to a different port if someone else is starting a Sparklyr application on that same node. So in a sense, it's a way of balancing, or more correctly, the term would be proxying to the right backend by keeping, literally, it's just a map that tracks sessions to the right port number. So with this approach, we simplified the ports files. It made our life easier, definitely troubleshooting customer connections. And it's also something, it's a change that enables us to support different, more modes. We haven't got to it yet, but this change would allow us to support things like yarn cluster, which is currently not supported on SparkR and neither on Sparklyr, to my knowledge, at least on SparkR. So definitely something that we would want to enable. Also, the Databricks connection that just got made available is reusing this gateway mode, because it basically provides a bit more flexibility while you're connecting to it with a backend. So I think unless we want to continue, we have 10 minutes for a break, and then we will continue. I definitely have a couple good demos, and we'll finish up this deep dive on the architecture. So I guess I'll pause here unless someone stops me from. Is it OK? Or we want to continue? We pause. Sounds good. All right, thank you.